Hello everyone. Today we are going to start the second lecture, and in this lecture we shall discuss about some important questions related to our previous chapter. And in that, the first question is, how does a charged body attract uncharged body? How does a charged body attract uncharged body? Means when we take a charged body, this is positive charged body, and when we bring it close to the uncharged body, then by the process of induction, that is a negative charge is induced at the closer surface and the positive charge is induced at the opposite surface. In this case, the negative charge is attracted towards this positively charged body with much greater attractive force than the repulsive force experienced by this positive charged surface. So since this is greater force, so the body is attracted towards this body. In this manner, the uncharged bodies are attracted towards the charged body. Again, I am repeating, when an uncharged body is brought close to the charged body, then the surface closer to the charged body gets negative charge and the opposite surface gets positive charge. This negative charge experiences much greater attractive force than this positive charge, so the whole body is attracted towards the charged body. In this manner, every charged body attracts the uncharged bodies. The second question is, like charges repel one another. Is it true also? It is true always? No. When we shall discuss about this with this man. In this case, for the second question, like charges always or repel one another, is it true always? The answer is no. When in a case when a body has a negligible charge in comparison to the other charged body, then in that case the body which has negligible charge is attracted towards the highly charged body, and in this manner it is always not true when a body of which is negligibly charged body is attracted towards the highly charged body. This is the answer of the second question. Again, I am repeating, like charges always repel one another. Is it true always? No. When a body has a negligible charge in comparison to the nearby charged body, then it is attracted towards the charged body. And the third question is, what does Q1 plus Q2 is equal to 0 signifies? What does Q1 plus Q2 is equal to 0 signifies? Or we take Q1 plus Q2 is equal to 0, then Q1 plus Q2 is equal to 0, then Q1 is equal to minus Q2. Means if Q1 plus Q2 is equal to 0, then both charges are equal in magnitude and opposite in manner. If Q1 plus Q2 is equal to 0, that means both Q1 and Q2 charges are equal in magnitude and opposite in nature. This is the signification of the Q1 plus Q2 is equal to 0. Now we shall discuss about the question number 4. What is quantization of charges? In the quantization of charges, what is quantization of charges? We have all discussed about the quantization of charges. What is one quanta? The minimum amount of charge by which a body can be charged, that is one electronic charge. This is called one quanta. And a body can have the charge equal to the multiple integral of this electronic charge, and we have discussed Q is equal to plus minus NE, where N is equal to 1, 2, 3, 4. Earlier we have discussed about it. So a body can have charge as the multiple integral of the charge. This is called quantization of charges. So what is quantization of charges? Quantization of charges is a body can only be charged by a multiple integral of electronic charge. Means a body can have one electronic charge, or two electronic charges, or three electronic charges, or five electronic charges. It never can be charged by the 1.5, 1.3, E by 3, 2E by 3. This is always multiple integral, but the recent research reveals that the charge less than one electronic charge is also considered, but it is not true. Still, it is not established fact, and now we have only n is equal to 1, 2, 3, 4, 5, 6, 7, 8, and a body can have charge the multiple integral of electronic charge. This is called quantization of charges. And the next question is question number 5. We ignore the quantization of charges at macroscopic level. Macroscopic level means 1 coulomb, 2 coulomb, 3 coulomb, 4 coulomb charges. And we all know that Q is equal to plus minus NE. And if we consider 1 coulomb charge, then N is equal to Q by E. The value of Q is 1.6 into 10 raised to the power minus 19 upon, 1 coulomb charge is equal to, here the value of Q is 1 coulomb upon 1 electronic charge is 1.6 into 10 raised to the power minus 19 coulomb. The number of corresponding electrons will be 6.25 into 10 raised to the power 18 coulomb number of electrons. And this is a very big and large number. So if we talk about the macroscopic level of charges, then the number of corresponding electrons for 1 coulomb charge is 6.25 into 10 to the power 18 number of electrons. For 2 coulomb charges, the corresponding number of electrons will be 2 into 6.25 into 10 to the power 18. For the case of 3 coulomb charges, the number will be 3 into 10 to the power, 3 into 6.25 into 10 to the power 18 number of electrons. And these are the very big large number of electrons. So in respect of, and when we talk about the macroscopic level, means 1 coulomb, 2 coulomb and 3 coulomb charges, then we have to consider such a large number of electrons, so we ignore the quantization of charges at the macroscopic level. These are the few questions related to my previous lectures, and now we shall discuss about some numerical problems of related questions, and this is all about the quantization of charges. Because only we have discussed about the Q is equal to plus minus NE. This is the related formula. Sometime in the numerical, the value of Q is given. E is, we all know about it, the value is E is 1.6 into 10 to the power minus 19 coulomb. Sometimes it is asked about the N, sometimes it is asked about the charge Q in the numericals, and the different kind of numericals we can see, but the basic formula of relate for the numericals will be Q is equal to plus minus N. In the case of numericals, the first numerical is if 10 raised to the power 9 electrons move out of a body to another body every second, then how much time is required to get the total charge of 1 coulomb? For the solution of this type of numerical, the question number 1, the number of electrons is 10 raised to the power 9 in 1 second, then the charge transferred to the body in 1 second will be, the 1 electronic charge is Q dash, we can write here, 1.6 into 10 raised to the power minus 19 coulomb multiplied by 10 raised to the power 9. So the value will be is equal to 1.6 into 10 raised to the power minus 10 coulomb. This is the charge transferred in 1 second, and the total charge will be is equal to Q is equal to 1 coulomb. So the the time interval for which 1 coulomb charge transferred will be 1 coulomb upon 1.6 into 10 raised to the power minus 10, and when we solve it, it will be 6.25 into 10 raised to the power 9 seconds. And if we want to convert it into years, the number of seconds 3.15 into 10 raised to the power 7. Now it will be converted into years, and the value will be near about 198 years. Again, I am explaining the number of electron transferred in 1 second will be 10 raised to the power 9. Then the amount of charge transferred from in 1 second will be is equal to 1.6 into 10 to the power minus 19 coulomb, and 10 to the power 9 is multiplied. Then the number of magnitude of charge that transferred in 1 second will be is equal to 1.6 into 10 to the power minus 19 coulomb. And Q is equal to 1 coulomb, so time will be taken is 1 coulomb upon 1.6 into 10 to the power minus 10, and the answer will be near about 198 years. This is the solved example in your NCERT book, and then after we shall discuss about the question number 2, and the question number 2 is how much positive or negative charge is there in a cup of water. How much positive or negative charge is there in a cup of water. The value can be calculated that the solution of question number 2 will be is equal to, this is the solution. Mass of water in 1 cup we can consider is near about 250 grams, and the molecular mass of water is equal to the atomic molecular mass of hydrogen will be 2 plus 16, so the total molecular mass will be equal to 18. And the Avogadro number will be equal to Avogadro number. We all know about it, and it is 6.022 into 10 raised to the power 23. This is the Avogadro. Now, 18 gram water contains molecules 6.022 into 10 raised to the power 23. Then 1 gram water contains molecules 6.022 into 10 raised to the power 23, and 250 gram water contains molecules 6.022 into 10 raised to the power 23 upon 18 into 250 multiplied. In one molecule, the number of protons and number of electrons are 10, and the value of charge on one electron or proton is 1.6 into 10 raised to the power minus 19 coulomb. And the corresponding answer will be is equal to, for the total complete charge will be is equal to 1.34 into 10 raised to the power 7 coulomb. This is the charge corresponding to the 1 cup of water. So this is the solution of second question, and then after we shall discuss about the question number 3. The solution of question number 3 is a polythene piece is rubbed with wool is found to have a negative charge of 3 into 10 raised to the power minus 7. Means when a polythene is rubbed with a wool, it acquires the negative charge 3 into 10 raised to the power minus 7. If a body loses the electrons, it acquires positive charge, and if a body gains the electron, it acquires negative charge. That means in this case, the polythene is the gainer substance and the wool is loser substance, and it acquires the electrons, and the corresponding number of electrons, the charge is given to us is 3 into 10 raised to the power minus 7 coulomb, and the electronic charge, we know that 1.6 into 10 raised to the power minus 19 coulomb. And the corresponding number of electron n is equal to, we can find out Q by E. The value of Q is 3 into 10 raised to the power minus 7 coulomb upon 1.6 into 10 raised to the power minus 19 coulomb, and it will be nearly equal to 2 into 10 raised to the power 12 number of electron transferred from wool to polythene. And because electrons are transferred, then in this case, is there a transfer of mass from wool to polythene? Yes, because polythene acquires negative charge, means electron transferred from wool to polythene, and the corresponding mass can be calculated. M is equal to N into mass of electron. The total number of electrons are 2 into 10 raised to the power 12 into mass of each electron 1.6 into 10 raised to the power 9.1 into 10 raised to the power minus 31 kg, and the total amount will be is equal to 2 into 10 raised to the power minus 18 kg. This is the negligible amount, but it is transferred from wool to polythene. So these are the few questions which I have explained to you, and then after I am going to give you the homework for 5 questions, and you have to solve it, and if you have any problem you can contact to me. Thank you very much.